Now we are going to solve the problem number 4.14, which is given in page number 220 in chapter 4, Electromagnetic Induction and Alternating Current chapter. First I will explain the description of the problem. Here one circular metallic disc, it is made to rotate within the uniform magnetic field. The area of the circular disc is given 0.03 meter square, and the metallic disc, circular disc, it is made to rotate within the magnetic field. The strength of the magnetic field is given, its value is 0.4 Tesla. Look at here, the axis, this is the axis with respect to that axis, that circular disc is made to rotate. Here, the direction of the magnetic field, that is parallel with the axis of the circular disc. Okay, so B is parallel to the axis. Therefore, the area vector, here area is there, no, its area vector is acting along the axis. Therefore, A vector and B vector both are acting in the same direction. And the circular disc, it possesses some resistance. The resistance of the circular disc is given as 4 ohm. When it rotates, it makes certain amount of revolutions per second, that is called F per second. The revolutions are given. The total number of revolutions made by the circular disc is 20. Okay, so 20 RPS is made by the circular disc. Understood? 20 means per second how many number of complete revolutions are made. 20 revolutions are made by the circular disc in 1 second. You are asked to find out the induced current and induced EMF which is generated in the circular disc. You are asked to calculate the induced current. Later you have to find out how much amount of induced EMF is created across the axis and the rim. So first you have to understand the problem, later we will work it out. First you should know the basic formula for EMF. How EMF is created? EMF is created by change in flux. Okay, so d pi by dt is a fundamental formula. When flux changes with respect to time, EMF is generated, induced, and then d by dt of, instead of pi, we can write BA cos theta. So pi is replaced by the formula BA cos theta because the formula of pi is BA cos theta. The next step, Xi is equal to, that is induced EMF is equal to, that B can be taken out, that is constant, it is not going to be altered, and then cos theta. Which one alone changes? Area alone changes. Area linked with magnetic field is changing. Are you clear? When the area changes with respect to time, flux linked with disk will also change. So in the next step we have to write induced EMF is equal to minus B. Here theta is the angle between A vector and B vector. Both the two vectors are acting in the same direction, therefore theta value must be taken as 0 degree. Therefore we can write it as cos 0, and then finally we can write dA by dt. First you should know how to obtain the formula. So finally the formula becomes minus B dA by dt is a formula which is required to solve the problem. Here first you should know what is dA by dt. How to calculate dA by dt? That is the thing. Okay. Here in the problem, what is mentioned is clear. You are asked to calculate the rate of change of area dA by dt. How to do this? Here, one important formula must be learnt. Area, here to calculate this part, area swept when it is moving in the circular path, rotatory path, clear, how much amount of area is swept out by the disc. Area swept within the magnetic field by the disc in unit time. The entire thing is nothing but dA by dt. That is equal to, what is the formula? Area of the disc, area of the disk, this is the most important formula, into revolutions per second. Revolutions per second is nothing but frequency f. Multiply both. Area of the disk is given 0.03 into how many revolutions are made by the disk in 1 second? 20. Therefore, 20 can be multiplied. 0.03 into 20. If both are multiplied, 0.06, 0.6 meter square. This much amount of area is changing per unit time. When the disk completes 20 revolutions in 1 second. This much amount of area is swept out, is it clear, by the disk in unit time. Are you clear? That is very important. Okay. So this formula is so important to find out. The entire thing is to be taken as dA by dt. Now xi is equal to, what is the value of B? 0.4 Tesla into 0.6 meter square. So the induced EMF will be 0.4 into 0.6. The answer would be 0.24 volt. The negative sign, it indicates that the induced EMF, it opposing the change in area, that is change in the flux, rate of change of flux. Okay, it opposes this opposing EMF. The EMF which is induced in the disk, that opposes the, which one? The change in area of the disk. So induced EMF is calculated. Our next aim is to calculate the induced current. For that we have to use Ohm's law. As per Ohm's law, we can write V is equal to I into R. Here instead of V we can write xi. Induced current can be written as small I. Are you clear? Into R. So to calculate the induced current, what we have to do? I is equal to xi by R. This is a formula. Substitute now. Okay. So after substitution you will get, here space is not available. That's why, clear, I am slightly move the camera down. Okay. Here space is available now. Substitute now. Xi is equal to, induced EMF value is already calculated, 0.24 volt. The resistance of the disk is given how much? 4 ohm. 0.24 divided by 4 will be equal to 0.06 ampere. So this is a value of induced current which is induced within the disk. Very simple problem. The only thing is, the most important step is which one? Finding the value of dA by dt. To find out the dA by dt, what we have to do? That area must be multiplied by revolutions per second. By multiplying this area and F, you will get dA by dt. Again I will write dA by dt can be obtained by area into F. Don't forget. So the area swept by the disk per unit time can be calculated by using the formula, this one. Provided if you know this particular formula, you can easily work out the problem. Okay, thank you.